we're going to spend some time grokking this problem. Part A is pretty straightforward. It'll involve some interesting algebra, but I think we can do that using our limits of the difference quotient. But then part B is something that is going to require some additional thought and some writing. And that is something that I really want to emphasize is important to learn how to do. So I'm going to start by A, and I'm going to find the slope of the curve at x equals A. In other words, at any point x in this curve, how am I going to calculate the slope? So that is going to involve the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So let's take our equation here and plug it into this limit. So I have the limit as h approaches 0 of 1 divided by x plus h minus 1 minus 1 over x minus 1, and all that is divided by h. Now pause for a minute and make sure you understand how I got my f of x plus h and my f of x. It's going to be a little bit confusing when we get denominators in there. So as I go forward here, I have a 3-level fraction, and I'm going to simplify my numerator first. And I'm going to do that by, I'm going to multiply, I need to have a common denominator, so I need to multiply my left one by x minus 1, and my right one by x plus h minus 1. So what I'm going to get is my limit as h approaches 0 of x minus 1 over x plus h minus 1 times x minus 1. So I'm getting a common denominator here. Minus x plus h minus 1 again over the same denominator here. So I multiplied really the top and the bottom by 1 to get a common denominator. Common denominator being x plus h minus 1 times x minus 1. And this is still all divided by h. So it looks kind of ugly, but let's see if we can't simplify it. So I have the limit as h approaches 0 of x minus 1 minus x minus h plus 1 divided by x plus h minus 1 x minus 1, again all over h. So I have the limit as h approaches 0 of, well, that x goes away and that x goes away, and the minus 1 goes away and the plus 1 goes away. So I have negative h divided by x plus h minus 1 times x minus 1. Again, all divided by h. And if I turn this division problem into a multiplication problem, I'm going to multiply this by 1 over h and multiply this by 1 over h. So those h's are going to go away. And this h is going to go away, so it's going to be minus 1. So I'm going to have the limit as h approaches 0 of -1 divided by x plus h minus 1 times x minus 1. Well, as h approaches 0, that gets me the limit as h approaches 0. Well, as h approaches 0, let's just solve it here. That's going to give me -1 divided by x minus 1, because h is approaching 0, times x minus 1. So that is equal to -1 divided by x minus 1 squared. This is the slope of the tangent at any point x on the curve of our function. So what I want to do here is I want to take a look at our function. I'm going to graph it. So here I've graphed the function. It's in blue right here. You can see the blue over here. I've graphed the function, and one of the things I can see here is that my tangent line, as I'm going from left to right, it starts out almost horizontal. I'm kind of drawing it. I hope you can see it. And then it starts to get increasingly negative. It gets very, very steeply negative as I approach my horizontal asymptote of +1. And then even on the other side of the horizontal asymptote, it's of course extremely negative up here, and it's still negative here, and it's still negative here, and it's staying negative even though it's approaching the horizontal as my limit approaches infinity. So one thing I can say about this is, one, my tangent is always negative. I should write this in a complete sentence. My tangent is always negative. And if I look at the equation, well, that makes a lot of sense, doesn't it? Because my equation is -1, which is a negative number, divided by x minus 1 squared, which is always going to be a positive number. So my slope of my tangent...
Excuse the interruption, Mr. Jenkins, are you there?
I am, yes.
Can you please go stop?
Sorry, I was interrupted. So we know that the tangent is always negative, both by our graph, we can see it on our graph, and we can see it on the equation of our slope. Another thing is that the equation of our slope is telling us, well, I'm going to have a horizontal asymptote, a vertical asymptote at +1. That's actually our equation of the graph is telling us that. So I know when I have a vertical asymptote, that my limits are going to be approaching either infinity or negative infinity. And so since I know that the slope is always negative, then I know that I'm going to have this kind of a design, but I might just write the slope approaches negative infinity as x approaches +1. That's something else I can write. The other thing I'm going to show you is this. So those are a couple things I could write about it. As x approaches, or as my a changes, and my a gets closer and closer to 1, I can write those things, and that, I'm going to be asking you to do that, to write it. But the other thing I want to do is I want to show you what does the graph of the tangent slope actually look like. This is something that is in preparation for the next chapters. So I put it right here. And this red now is the graph of the tangent slope. It's not the graph of the tangent, it's the graph of the slope of the tangent. And as you can see, it's always negative. It's always below the x-axis. It is a negative number. And as you can see, as I'm approaching x equals 1 from either side, the slope of my tangent is approaching negative infinity. So I can actually use the graph of the slope of the tangent to tell me things about what the graph is going to look like. Now, that may be a little bit overwhelming. You don't need to know this right now. It might be helpful. It'll definitely be helpful if you understand that as we move forward.